Hello students, we have introduced the concept of moment of inertia. Now it's very important to understand as to what exactly is the center of mass, because our radius of gyration, or for that matter any point about which the mass is said to be concentrated, or how we can symmetrize all the masses, that depends upon the center of mass. So center of mass is basically going to be the point where the complete mass of the body can be said to be concentrated. And we'll also try to learn about center of gravity. So let's listen to this lecture and we'll try to take it further.
So centripetal force, so like we have discussed before as well. So supposing you have an object that is moving about an axis. So when it is moving about an axis, so this is, let's say, a top projection. So if you try to take the snapshot view, so this is going to be how it's going to be moving. So let's say v is the velocity with which this object is moving in a circular path with an angular velocity omega. So at this point there is going to be a centripetal force that will be acting towards the center. V is the velocity and omega is the angular velocity. As a result, what will we say? We'll say that the centripetal force is going to be given by mass into the acceleration. So this is the centripetal acceleration which we have defined before. So this goes as m into v square divided by r. So this is what is the centripetal force that we get. Further, the velocity. The velocity is going to be given by r, which is the radius, and the angular velocity. So if I want to find out in terms of this particular relation, if instead of that, if I replace it by this, so I'll get mr omega square. So that is going to be the value of the centripetal force. So this can be used to simulate gravity. So using this gravitation, basically supposing this is the person that I have, so this force is going to be, so supposing this object is moving, in that case you can simulate gravity by moving with that particular amount of angular velocity, thus that you can actually feel a kind of force which pushes you in the outward direction. Or at the bottommost point, because of rotation, you will feel that there is a force that is pushing you downwards. So this is what is done to simulate gravity. So here you have the radius r. So using this, we know that F is equals to mr omega square. So G can be related, and it can be found that it can be written as r omega square. Further, F is equals to m into G. So using that, we can understand that with this particular value of angular velocity, I can find out, or I can get this particular amount of acceleration. So if I can do that, so that is going to simulate gravity, right? So on that note, I end it here. In our next part, we'll try to understand about the rigid body motion, how the rigid bodies actually move when they are translating as well as when they are moving in a particular path.
So students, we learned about the difference between the center of mass and the center of gravity. Essentially speaking, as we discussed as well, the center of mass and the center of gravity are going to be at the same point, unless we have a variable gravity, because the center of gravity is going to play a different role when the gravity is different, right? So hope you have been enjoying till this point. Stay tuned and I'll come back to you with the next lecture.